Good day and welcome to Math 111H Calculus 1 Honors, The Joys of X. On today's show we're going to discuss the chain rule. Consider the function y equals f of g of x, and we want to take the derivative of this composition of functions. Well, what's really happening in a composite function like this? Well, we have x causing g to change, so a change in x causes g to change, and then a change in g causes f to change. And we want to understand the influence of a change in x on how f changes. So the result will be that the change in y is just the product of the change caused by x to g and the change caused by g to f. So for example, if we have this blue ball representing a gear, and suppose you turn this blue ball around once, and turning the blue ball around once maybe turns the green ball around 3 times, and each time you turn the green ball around, it turns the red ball around 5 times. So what would happen if you turn the blue ball around once? What would happen to the red ball? Well, you turn this around once, the green ball goes around 3 times. Each time the green ball goes around, the red ball goes around 5 times. So we multiply that, the 3 times the 5. So the change in the blue ball causes a change 15 times as large in the red ball. And that's kind of what's going on here. The change in x causes a change in g, which causes a change in f, and that the change in f or in y is just the product of those two changes. Formally, we write d dx of f of g of x. We can plug in the definition of the derivative. That's the limit as h goes to 0 of f of g of x plus h minus f of g of x over h. Then we play a little trick. We multiply and divide by the quantity g of x plus h minus g of x. Notice that that would just cancel out if h is not 0. And so what we get on the right, well, that's simply g prime of x. On the left, what is that? Well, that's the change in f divided by the change in g, or df dg formally. So we have that the derivative with respect to x of f of g of x is df dg times dg dx. Let's just do one example. Consider the function f of x is the square root of x plus 1. So we'll let little f of x equal square root of x. Little g of x equals x squared plus 1. So f of g of x will be the square root of x squared plus 1, which is big F. And we just learned that the derivative big F prime of x is little f prime of g times little g prime of x. F prime of g, well, the derivative of the square root is 1/2 times x to the minus 1/2. But if the function is f of g, we're taking f prime of g, so we get 1/2 of g to the minus 1/2. And we also need g prime of x. And g prime of x, well, if g of x is x squared plus 1, g prime of x is 2x. So we get f prime of g, 1/2 g to the minus 1/2 times g prime of x is 2x. We plug in for g is x squared plus 1, cancel the 2's, and we get that the derivative of big F with respect to x is x over the square root of x squared plus 1. A moment for math culture. There was a time when in college it was required that in order for a student to receive credit for a course, a card listing his or her courses had to be signed by the instructor. It was at that time policy that the students attend their courses. But depending on the size of the class, it was often quite possible to receive credit even after not attending the class regularly, because if it was a large class, the professor typically wouldn't know all the students. But it wasn't true with that math professor. If he didn't recognize you, you would have to repeat the course and attend. On one occasion, a student handed his card to be signed. The professor looked at the name, then at the student, and said, "I've never seen you in my class before." And he handed back the card. Now, being a math student, the student naturally thought quickly and proceeded to the end of the line. When he was at the front of the line again, he handed his card to the professor. The professor looked at the name, looked at the student, and said, "You look familiar." "Okay," and he signed the card. Thank you for joining us today. Have a great day, and may the power of math be with you.